Alright, so a short digression here into some physics. If you've been in physics class, you've probably seen some of this before, but I'm going to do a really dumbed down version of it. Current, charge, and some damped functions. So you may not have seen the damped functions bit of current and charge, but we'll talk about that. Alright, so here I've got my electrical circuit. I'm going to plug it into the wall. This is my power point. Here's my switch, and it's an electrical circuit. Goes through here, through the light bulb turns on, and it comes back around again. Alright, so we need to talk about current and we need to talk about charge. So there's some amount of charge that turns our light bulb on. Okay, so the brighter the light bulb, the more charge we have. And we're going to use the letter Q for charge. And charge is usually measured in something called coulombs. C-O-U-L-O-M-B-S. Right, lowercase q for charge. Now, charge is related to something called current. So electricity is electrons moving through our circuit. So the amount of electrons is captured by something called amps. But another way to write amps is, instead of writing amps, you can write coulombs per second. Coulombs per second. So charge per second, if you like. Now what that means for us is that these are related by a derivative or an integral. So amps is the derivative of coulombs. The change in coulombs with respect to time, let's use time or seconds or whatever, milliseconds, whatever it is, that's a time function. Okay, so derivative, and of course, if you knew the amps, coulombs, we can go back the other way. Derivative, integral, derivative, integral. Now, just to confuse matters slightly, amps, which is the current, whoops, we're going to denote that with the letter capital I. So current, capital I, coulombs, Q. So we can write I equals the change in charge with respect to time. Done. Alright, so current, charge, but what about damped functions? So I haven't flicked my switch yet, but when I turn on this power, something called AC current comes through, alternating current. Now, you may have been playing with amp meters in physics before. What will happen is, if I turn this on, if I have an amp meter here, the needle on the amp meter is going to swing as heaps of charge comes through here, and then it will calm down, and then it will steady on down to a certain level. If you had like a high-speed camera, when you turn this on, the light is going to shine really brightly, and then dimmer, and then more bright, and then dimmer, and then it's going to settle down to a point. So the amps are going to follow this guy here, a dampening function. That's all we need to talk about there. Now we just get stuck into the raw calculations.